In this video, we'll use factorial and double factorial to generate the Taylor-Maclaurin series sum of the Gauss function, which is in the form of square root of pi times Gauss of the quantity x times square root of 2, where the value of x ranges from negative 2 to positive 2. We give you the formula of the expansion, which is the summation of a times 2 times x to the power 2n plus 1. A can be in the form of a1 or a2, and the value of n from 0 to infinity. We start from 0 up to infinity. 16 is good enough. Now we continue with the factorial coefficient. So R formula minus 1 raised to the power n. That's f3 to f19 divided by, so we copy this value of n, we copy this, okay, and we continue. Divided by, there are two parts, factorial n times the second part, the quantity 2n plus 1. So the quantity 2 times n plus 1. And so here's the factorial coefficients. We continue with the double factorial coefficient, which is R formula minus 2 raised to the power n. That's the first part. The second part. The second part is double factorial. So double factorial. Double factorial of 2 times n, that's 2n minus 1, so minus 1. We just completed the numerator. Now the denominator. There's only one item in the denominator, so we have factorial 2n plus 1. So 2 times n plus 1. Then enter. We have to correct this first item. All these are the same except for the first item. So we use the if statement. So the quantity array formula if n equals 0. If n equals 0, 1. Otherwise, calculate. Now they're exactly the same. We can now continue with the expansion, which is array formula SERIESSUM of the x values raised to the power 2n plus 1. 2n plus 1 starts from, at n equals 0, that's 1. So 2n plus 1 starts from 1 and continues with the next one. 2 times 1 plus 1 is 3. So 1, 3, 5, 7, 9. The increment is 2. And the coefficient, you can choose double factorial or the factorial. We start with the factorial and enter. And we chart this. Insert chart. And we use scatter chart. Row 1 as header. And we show the trend line. Polynomial to the 8th degree. For the label, use the equation. For the legend, position at the bottom. Here's our trend line and the polynomial. So that's the trend line and the polynomial. We continue with the Gauss function, which is equal to our formula. Let's start with the Gauss function. Gauss of x. That's the Gauss function. No equation, so we have to show the equation. Edit chart, series, trend line, polynomial to the 8th degree. For the label, use the equation. We'll calculate the polynomial regression coefficient using LINEST. To do that, we start with the power. This will be transpose of the x values. Now the elements of the LINEST matrix, which is array formula of the x values raised to the power 0 to 8. Now we can use LINEST. This is equal to LINEST data y and data x. And this is also LINEST data y and data x. Now we modify the Gauss function. So they're different because we haven't modified the Gauss function. There's a square root of 2. So times square root of 2. And then right outside Gauss, you have square root of pi. So times square root of pi. And enter. Now they're all in the same trend line. And the polynomials are the same. So we inspect at x. So x to the 0 at 0. Coefficient of x 0.997. Coefficient of x squared 0. Coefficient of x cubed minus 0.313. Coefficient of x to the fourth 0. Coefficient of x to the fifth 0.0696. Coefficient of x to the seventh, that's minus 6.54 times 10 to the minus 3. X to the eighth 0. That's because we use the double factorial. Suppose I use the factorial. So we change this. Then enter. We still get the same polynomial regression coefficients. The polynomials remain the same. The trend line is still the same trend line, and the data sets remain the same. This completes the use of double factorial and factorial in the Taylor-Maclaurin series expansion of the Gauss function and its LINEST polynomial regression.